Okay, I am ready.
I have any time Saturday or Sunday.
Okay. Quiet, please. Okay, for 2 days you did law of sines. Yep, you're writing this. I'll let you know when you can stop writing. Law of sines, we needed angle, side, angle. Or angle, angle, side. Okay, we are. The law of sines also works for two sides and an angle if it's in the position of angle, side, side. But the problem with angle, side, side is angle, side, side doesn't create a unique triangle.
Remember the example we had in our assignment where we had side, side, angle, and
Yep.
another angle?
Yep.
Does that like work for?
Yep, it's going to work right now today. See, like I said, that was a misplaced problem. It should have been in this section. So, also, it works for angle, side, side.
There it is!
There it is. We got to talk about angle, side, side for a little while before we can move on. Angle, side, side does not always create a unique triangle, which is why it wasn't one of your postulates back in geometry. Unique meaning one and only one triangle. Okay, I'm not going to make you copy the book. I just want to show you this case. It's all explained nicely on page 291, but you don't need your book open. I'm going to stick it under here. I'm just going to talk about it so you can stop writing and look at the angle side side case. So first, it's on page 291, but it's all right here. You don't need your book open. If you're given angle in angle, like they're showing you, you're given angle A, you're given side B and side little a. If your angle A is acute, one of four things can happen. Okay, first of all, if the side across from A is too short, you don't even create a triangle. It doesn't quite connect to make a triangle. So there might not even be a triangle with the three parts angle, side, side. That's one option. If the other angle is a right angle, it will create a nice, unique right triangle. You get one triangle.
How's that unique?
Because there's only one of them. If I gave you this angle measure, say it was 10 degrees, I gave you that side, say it was 15, and I gave you this side, or whatever it happens to be, and I gave you those three parts, everybody would have to build the same right triangle with this right angle. Everybody has to build that. That's what makes it unique. This one, if the opposite side is greater than the adjacent side in the three parts, that also creates a unique triangle. It's an obtuse one. This is the case here. If the opposite side is smaller than the adjacent side, but bigger than the height, it creates two triangles with those three parts. And they're showing you right here. This angle's given, angle A, this side's given, and this side A. I can make this third side really short and get this triangle. Or I can take that A and swing it way out here. That just increases this bottom side. And I've got two triangles that have the same angle, and the next two sides are the same. Two different triangles there. So that's if your given angle is acute, one of four things can happen. No triangle, two spots where it's a unique triangle, and here where it's two different triangles. If your given angle is obtuse to start with, and then we've got these next two sides. They needed the third color here is really what they needed. You might not get any triangle again if that opposite side is smaller than the adjacent side. Or you might get one unique triangle if the opposite side is greater than the adjacent side. So, we call this the ambiguous case. You're not going to have to memorize this, because when we start solving the triangle, everything just falls into place. You'll start solving, if there's no triangle, you'll get an error. You can't solve it if it doesn't exist. That just happens when we start to do the math, the calculator works. The only thing you have to do is remember to check for the second triangle. If you remember that, everything works out fine. So we're going to do 3 examples today of the ambiguous case, which is angle, side, side. So, If you've got angle side side, we call this the ambiguous case. Where there could be no triangle, one triangle, or two triangles. All we've got to do is remember to check for that second triangle if we get a first one. So, are you ready? Here we go. These are all solve the triangle if possible. Solve the triangle or triangles. Oh, I suppose I wanted that. Triangles. Those don't need to be there. If possible. Okay, so if angle B is 100 degrees, little b is a length of 61, and little a is a length of 82. Alright, I'm going to draw a triangle. I'll start assuming that I might have one. Label, obviously, I'm going to go with ABC. And I don't even care that it's not to scale, it doesn't matter. B is the 100 degrees. Little b, make sure you get it in the right spot, is 61. And little a is the 82. Now this is where you're going to have to pick out what three parts do I have here. Because if you can't pick out the three parts, you're not going to remember to check for the second triangle. This is angle side side. Ooh, angle side side means I got to remember to check for the second triangle. Two triangles maybe? Question mark. Two triangles? Maybe, just to keep it in your head. So anytime you get angle side side, you got to remember to check. Because I guarantee if you miss it on the quiz, so we're having two quizzes in this chapter instead of test. Yeah. So what's going to happen is once we get through all of these, we're going to actually make programs to solve the triangle for the second half of the chapter where it's all story problems. Kind of cool. So anyway, what you have to show me that you can do this. But anyway, if you miss the angle side side and you don't do the second triangle, you can't get an A on the quiz. It's impossible. So, to your advantage to keep writing down what three parts are given. Alright, so we're going to start with law of sines. We can find everything, we can solve a triangle with law of sines if I have angle side side. So we're just going to start solving like I think there's a triangle, at least one triangle to start with. So what proportion can I set up? You know, I've got a side and an angle. I can't find the other two angles. It's impossible. I have to start with some trig. So I'm going to set up 61 over the sine of 100. What does the other proportion have to be? Over sine of A. So, we're going to cross multiply and divide, and that will give us the sine of A. Not angle A, but the sine of A. So do your cross multiplying and dividing. Better do this. What are we getting here? Oh, I'm in the wrong mode. Oops, mode. Degree. 82 times divided by 61. What'd you get? 1.3238? Okay, how do you get the calculator to give you an angle? If you know the sine ratio. Inverse. Why is it not working? It's over 1. So why is it coming up over 1? Yeah, these three parts don't actually make a triangle. It's that first case where the opposite side was too short to make it work. See, the opposite side was too short to make this thing work into a triangle. But did you have to know it to start with? No, you get an error here. We'll give you an answer. So when you get an error, that just means there was no triangle with those three parts. Can't solve it if it doesn't exist.
Is there any way to find it before you do the work?
Yes, you'd have to look at, you would have to use that page that I gave you, say I've got the obtuse angle, and if you look on that page, I closed it up already,
Yeah.
you gotta look at the opposite side and compare it to this. There's a whole big table of things we could do, but that's more work than just starting it, trust me. So that's why I don't bother having you check ahead of time. Because then if you check and make a mistake, and you don't solve a 2 triangle one, then you're really out of luck. So, no triangle there. Okay, second one.
You could have a triangle in any circumstance at all.
Yep, this is the case where these 3 parts will not make a triangle. Try all you want, you will not make a triangle with this.
And that's because 61 isn't long enough.
Isn't long enough because that's 82. It's going to be hanging up in the air there. Okay, number 2. Let's go. B equals 54 degrees. This is an acute angle. There were 4 different cases for the acute angle. Could be no triangle, could be a right triangle, could be a unique triangle, or 2 triangles. Little c is 28 inches. B is 23 inches. It doesn't matter where you start your A, B, and C. Just label everything correctly. So go ahead and label. Make sure you're doing things correctly. Don't just copy. It helps to practice on your own. Yes?
Did I sense why you're mixing up the order? No?
I don't know.
Oh,
Just because I can.
Oh, okay.
Yep. It doesn't always have to be the same way.
Okay, thank you.
Because once I've established A, B, and C, everything's in reference. So if you were to put yours differently, mine is just a rotation of yours. I could get them to match up. Okay, what 3 parts do I have? Angle, side, side again. Oh, that angle, side, side. Is there 2 triangles here? I don't know, but I'm going to check for it, and I'll show you how to check for it if we can actually get past the first one. We didn't get past the first one in example 1. So, you just start solving like you know what you're doing, law of sines. What proportion am I going to use? We've got the 23 and the opposite angle 54, so I got to start there. So 23 over sine of 54 equals the other proportion? 28 over sine of C. Okay. This one, you do your cross multiply and divide, you will have sine of C, not angle C. How about 0.9849? Agreed? Those that tried it? So to get C, we should get a value here because it's not over 1. What is the inverse sine of that value? 80 even? Or rounds to 80? 80 degrees? Okay, so we do have at least 1 triangle. This is the spot where now I'm going to make a little table to keep track in case I have a second triangle. So triangle 1 and triangle 2. So angle C is 80 degrees. To check for the second triangle, it's right here, right now. Once you see you've got one, you can do a big old OR. Okay, roll off to the side for a second, so don't write this down. We just did a sine ratio of 0.9849. There are